about parallelograms and nothing else. So we're going to mark up this picture with the different properties that are listed below. So first, well, before we even get started, parallelograms, what's the like root word there? Parallel. And what does parallel mean? No, I just mean the same. Right, lines never intersect, lines never touch. So in a parallelogram, you've got two pairs of parallel sides, hence why it's called a parallelogram. In the picture, we're going to mark that up. Who remembers the symbol that you use to mark in the picture that something's parallel? These two, that's if I'm writing it as a sentence. Yes? Arrows. So if I'm writing as a sentence, like Stevie said, yes, I would put two lines like this. If I'm marking it in a picture, I need to put arrows. So we're going to mark one set of our sides as parallel and the other side as well. So I'm going to do one set of arrows on one side and then two sets of arrows on the other side. Doesn't matter which way or which ones you do one and two. But we're just showing that they are two sets of parallel sides. Next property says opposite sides are congruent. Congruent means what? The same. What do I use to mark congruency in my pictures? What do I have to do? What do I have to draw? A little tick mark, yes. So I'm going to mark that they are congruent with one pair of tick marks for one side and two pair of tick marks for the other side. Okay, easy peasy so far. Number 3. Opposite angles are congruent. So angles that are essentially diagonal from one another are considered a cross, and they are congruent. So these two small angles here on the lower left and the upper right, those two are considered congruent, as well as the other two, the larger ones. These are also a set of congruent angles. So you've got two sets of congruent angles, two sets of congruent sides, and two sets of parallel sides. Next one says consecutive angles are supplementary. What does supplementary mean? Adds up, bless you, to 180. So consecutive means two that are on the same line. So for example, if I said that this small angle on the lower left was 80 degrees, this one over here is on the same line, what would this one over here have to be? 100. And then what would this one over here have to be on the same line? 80, yeah, 80 and 80, these two are the same, and these two are supplementary. And then what about this one? 100, yeah. So hopefully what you're noticing in parallelograms is it's a lot of the same thing, right? Like over and over again. Last part is that diagonals bisect each other. What does the word bisect mean? Anybody remember? What? Splits in the middle. Good. So diagonals in the picture down here, they're these dotted lines right here. So if you're cutting them right in the middle, that means the two pieces that are left are the same. So like this line right here, if I wanted to, this one and this one, these two little pieces are the same. Same with the other two sides as well. Another pair of diagonals that are bisected. So today we're only going to talk about parallelograms and nothing else. And we're going to use this picture to kind of figure out how to set up our equations for each one. And I think you guys are going to breeze through it easy peasy. So take that paper, push it off to the side, but keep it out. And we're going to look at the packet now, the little packet. The packet is pretty self-explanatory. Each page is its own type of quadrilateral. But the front side's notes, back side's homework, front side's notes, back side's homework, and so on and so forth. Okay, so it's essentially the whole chapter. You've got your notes and your homework right in front of you. Okay, so don't lose anything. So for numbers 1 through 6, we're going to solve for x, And then it also tells me that each figure is a parallelogram. So we're going to use that information as we answer each question. So number 1, you've got a parallelogram there and you've got 2 equations. Are we talking about side lengths or are we talking about angle measures in number 1? Sides or angles? What do you think? How did you decide that? Why angles? Mm-hmm. Yeah, so this is an angle here and this is an angle here, but I'm saying this whole piece is 4x plus 5. So is that a side or an angle? That's a side. That's okay, so it's on the outside. So I'm going to write the word side next to it. Now, you've got 2 sides. They are across from each other on my parallelogram. If I look back at my picture, what do you know about sides that are across from each other? Yeah, they're parallel and congruent. So these 2 pieces are the same. If they're the same, what do I do with the equations? Set them equal. Yep, that's it. 4x plus 5 equals 6x minus 3. And then it becomes the easiest algebra ever. That's all we're doing today, straight up algebra. So I'm going to start by subtracting my 4x from both sides. So I like to move the smallest x first, so I don't have to deal with negatives. Then I'm going to get all my constants to the other side, so I'm going to add 3. I get 8 equals 2x. And then last step is divide by 2. What do I get for my x value?
4.
Beautiful. Now, if I wanted to check my work, what could I do? Plug it in. So if I plug it in, I should get the same answer on both sides. 4 times 4 is 16, plus 5 is 21. 6 times 4 is 24, minus 3 is 21. Boom, I got that problem right. And that's it. That's all we're doing today. So it's just algebra with a picture. Your fate. Questions? Feeling good? Easy peasy, right? All right, number 2. Am I looking at sides or angles in number 2? Angles, how do you know? It's on the interior, and one of them even has a degree symbol next to it. So these are angles. Okay, so if we look at their location, M and K are across from each other. If I look back at my picture, what do you notice about 2 angles that are across from each other? They're congruent. They're the same. So what should I do with these equations? Set them equal. Yep, that's it. So angle M is equal to angle K. So hopefully you're getting that this is just some really easy algebra today. Yeah? Not bad. So that's what? 77? Yep. And then divide by 7. X equals 11. Again, if I wanted to check my work, I could plug it in, but I'm not going to because I'm right and I'm never wrong. So I'm not going to check it. All right, friends. Tough crowd here. It was a joke. All right, cool. You guys are really awake today. Okay. I'm going to do like one more, and then I actually really think you probably don't need me for the rest of the front side. I'm going to do, I guess I will do 3.
Oh, number 3 is easy.
3 is easy. Why don't we do 5? Let's
5.
I'm not doing 10. Oh my gosh. I'm going to do 5 and I'm going to do 8. Okay, great. 5. Now, number 5. Are these angles or are they sides? Angles. Okay, so always, personally, I would always go for it because that's going to tell you, whoa, my goodness. That's going to tell you how to set the equation. Now, you've got angle K over here and you've got angle L, but what do you notice about angle L? It's being split into 2 pieces. Well, if I wanted to know the total of angle L, what would I have to do? Yeah, just add them together. When you add them, what do you get? You get 56 degrees. So angle L is 56 degrees. Angle K is 124x degrees. Now, these are at the top of my equation, or the top of my parallelogram. If I come back over here, what do you notice about the angles at the top of your parallelogram? They equal 180. So how would I write this as an equation? Exactly. So you're going to take angle K and add it together with angle L and set it equal to 180. So you've got some choices. You can write it as, you can write 56 here, or you could write 27 plus 29, just one extra step. Okay, but then it's just some straight algebra again. So I'm going to subtract 56. I get 5, 6, 7, 8, 3, 124. Meaning x is,
so I could lose 1.
ta-da, easy peasy. I know, it's not supposed to be hard. So look, here's the whole deal. You literally have two choices today. Choice 1, if they are side lengths, you're going to set them equal because they're congruent. If they are angles, if they're the same, you set them equal. If they are different, you add them up to be 180. So you literally only have those two choices. Set them equal or add them together. Equal to 180. That's it. If one doesn't work, I guess try the other one, but it should be pretty self-explanatory. Question. So you will add it up to 180 if your angles are next to each other on the same line. That's the only time you'll add it up to 180. If your angles are across from each other, you'll set them equal. But that's it. Okay, I'm going to do one more with you, and then I'm going to let you finish the front with the people at your table. We'll check it at the end. Nope, I'm going to do 8. Ha, I'll do 8. Last one. Okay. Now, number 8. What's a little different about number 8? What's different? It's split in the center there, right? So you've got these pieces that kind of split it up into smaller triangles. Those pieces are called diagonals. So this problem, I'm going to write down that these have diagonals. Okay, here's what we're going to do. We're going to label the picture based on what's given to us. So the first thing I gave you is that HI is 2x plus 7. So on my picture, HI is right here. I'm going to put 2x plus 7. Second thing I give you is that IF is 5x minus 23. That's this piece here. Okay. Now you've got your two pieces. So you've got two pieces within the diagonal. Now, if you come back to your little cheat sheet, your picture here, what do you know about diagonals? What does that cheat sheet say? Yeah, they bisect each other, so they are congruent. So if they are congruent, what should I do with these equations? Set them equal to each other. That's it. And then it becomes your fave, algebra. So half the battle is just, can you write the equation? And the rest is algebra. my gosh. Okay, that was a lot of work. Now, got a little bit of algebra happening. I got x equals 10. So I got all my constants to one side, all my x's to the other. Am I finished with the problem? No, why not? Okay, now, HF is the entire thing. What would I have to do to figure it out?
Combine those lines.
You can combine, yeah, you can plug it in and then just add the two together, or you could plug it into just one and you don't need to plug it into both. Why not? Ah, they're exactly the same, so you don't need to do that much work for it. So let's plug it into one of them. Doesn't matter which one. I'm gonna go for the first one because that's easier. 2 times 10 is 20 plus 7 is 27. So HI is 27. What does that mean IF is without doing any other math? It's also 27. So to figure out the full length of HF, yeah, I just add the two together. And what's 27 plus 27? 54. So my answer for HF is 54. Okay, now you've got some other problems to do. They're all set up like ones we've done so far. I'm telling you, you only have two choices. You either add them up and set them equal to 180, or you set them equal. If they look the same, set them equal, okay? So you're gonna take the rest of the time. I'm gonna give you about, so 40, yeah, I'll give you 10 minutes. We'll see how far you get in 10, okay? So I'm gonna check them. So take 10, work with people at your table. Let's see how far you can get. Which means, yeah, you can talk.
Wait, you need 4?
Also make sure you're reading the question. See if it's asking you to solve for X or if it's asking you to plug it in. So read those questions.
So you just add the 2 sidelines together.
Stop recording.